Marlena Giatina. I'm a graduate from the University of South Alabama. I have my Bachelor of Science in Geography and I am GIS certified.
Hi, my name is James Pickett and I'm a mathematics major at the University of South Alabama.
Hello, my name is Rachel Osmorning and I'm studying meteorology at Embry-Riddle Aeronautical University.
Hello, my name is Shikhar Mishra and I'm a graduate student at University of South Alabama studying electrical engineering.
Hi, and thanks for joining us today for our virtual poster session. I'm Walt Clark, the center lead for the Mobile County Health Department NASA-developed location, and for the past several months, this has been the location of our research. To serve a growing population, Mobile County constructed a dam in 1952 across Big Creek to create this drinking water reservoir, Big Creek Lake. However, in the past 4 years, new construction on US Highway 98 north of the lake has caused many concerns. Immediate concerns have been sedimentation as well as successive urban growth.
MOSS, the Mobile Area Water and Sewer System, is concerned with potential development that this new highway may bring. In order to assess the effects of an extended road system through the watershed, MOSS partnered with the Mobile County Health Department NASA developed team to research the effects of a developing highway through the watershed by modeling urban development using the urban growth model, SLEUTH.
SLEUTH is an urban growth model that uses historical data and imagery to make conjectures about an area's historical urban growth pattern in order to predict future urbanization. SLEUTH has 5 parameters which govern the algorithm driving this prediction. They're based off of its inputs, which are a set of raster images representing the area's geographic characteristics. SLEUTH is an acronym standing for its inputs: slope, land use, exclusion, urban extent, transportation, and hillshade.
The SLEUTH model requires that we have a minimum of 11 inputs to run the model. For our project, we have 2 land use layers, 1 slope layer, 1 excluded layer, 4 transportation layers, 4 urban layers, and 1 hillshade layer for a total of 13 inputs.
The inputs for this project were first obtained from satellite imagery obtained from the Landsat 5 thematic mapper sensor and the Aster sensors. These images were then manipulated in ArcGIS and AirDOS Imagine software in order to get them to the proper format.
SLEUTH uses these inputs during its calibration process to determine the weight of each parameter for the given scenario. In essence, the calibration process determines various growth coefficients that govern the pattern of urban growth within the subjective area with the help of various input images with a specified format.
So team, and what has our 10 weeks of research culminated?
Our total simulation area was around 150,000 acres and we ran the prediction up till 2050. And model predicts that there will be 49,000 acres of urban area in 2050 without the highway.
Wow, so how did those numbers change with the new highway?
That will be around 51,000 of acres. So there will be a difference about 22,000 acres. But the important to notice is that most of the urban growth is predicted near the Big Creek Lake.
So while the primary focus of our research has been on urbanization within the Big Creek Lake watershed, we can't ignore the effects of urbanization on water quality.
Exactly. The primary cost concern for MOSS and water processing is organic carbon that can react with chemicals in the water treatment process to create carcinogenic and EPA-regulated disinfection byproducts.
Well, how is urbanization within the watershed tied to carbon loading within the lake?
Well, really, James, it's in several different ways that you have to look at. First thing you have to consider is that the initial construction of these buildings within the watershed releases a great amount of sequestered carbon that's in the soil, which can then flow through the tributaries and into the lake. And then also you have to look at the deforestation that comes from this urbanization within the watershed. And this just allows for the diminishment of natural groundwater filtration processes that work. And then last of all, it's been shown that urban runoff is much greater in nitrogen and phosphorus. And then these chemicals lead to eutrophication in the actual lake, which lead to algal blooms. And these algal blooms are another major source of carbon loading for moss.
So what is some more work that could be done to build on this research?
There has been recent research specific to the Big Creek Lake that uses a watershed model to model the disinfection byproducts based on land cover. And this research used the same land cover data sets that we use to run our SLEUTH model. Dr. Emily Elias, her dissertation on the Big Creek Lake quantified the value of land cover to moths. And using our predictions and these techniques, we could provide a solid foundation of what the expected carbon loading or disinfection byproducts would be due to the urbanization.
Wow, excellent. That was great.